K radians per second squared. Okay. Can anyone solve this using your calculator? You can? So you can do 3 by 3 or whatever, right? You can? Okay. So if you can do that, even better, okay? But if you can do that, most important thing is this function over here, right? Most important thing is this function over here. Are we clear? Okay, if you can do that in your calculator, like using your solver, do it. Are we clear? If not, do what I've just shown you. Okay. Now we are going to use a lot of cross product. Are we clear? Okay. So later on, I'll show you what I'm preparing in class. Okay. Oh, not this one. Okay. So later on, we'll go for. Is it here or prep? Okay. We'll go for more complex stuff. Like we are going to do all this. Okay, so we are going to analyze. Oh crap. Okay, so this is what you'll be doing in like 1.5 weeks time. Look at all this. All right. Okay, and then we're going to do analysis like structure like this. Okay, so all this we're going to apply a lot of what? Cross product. Are we clear? Okay, so get used to it. The math is simple. The analysis, we have to be careful. Okay, that's all. Anything more complex, no. Okay, right. So we are going to go on to the next topic. Okay. So the next topic that we're going to cover, right, is going to be the absolute motion analysis. What I suggest is I will teach until 10:05, then we go. Is that okay? We don't need a break. Is that okay for you all? Okay, thank you. Okay. So this is a new section. Okay. So when body is subjected to a general planar means 2D, okay, motion, it undergoes both simultaneous translation and rotation about a fixed reference point. Okay. The thing to take note is about fixed reference point, and we're dealing with what? General planar motion. So I'm going to show you what general planar motion looks like. It's something like this. Okay. So if you want to refer what do we mean by general planar motion, this is what general planar motion can look like. Okay. So motion can be specified by knowing both angular rotation of a line, okay, fixed in the body, and the linear motion of a point in the body. Okay. So what we tend to do is we tend to use a rectilinear position coordinate system. Okay. So I'm going to get this image again. Okay, I'll let you finish copying first. Okay. So what we tend to do is we tend to have a transformation rectilinear position. So this is our x and y. Okay. So we tend to use a rectilinear position coordinate to locate the point along its path. Okay, I'll underline the important words. Okay. To locate the path along its path and angular position coordinate theta, okay, to specify the orientation of the line. Again, another term that you have to take note. Okay. Then after that, once we have this, so we have both linear motion and angular, then we are going to apply v, velocity is equal to ds over dt, right? And acceleration is equal to dv over dt, okay, for linear motion. And then we're going to apply omega equal d theta over dt, and alpha is equal to d omega over dt. This is for angular motion. Okay. Okay. It does not look that bad. Okay, you're like, oh crap, what is this? Okay, let's do an example. Okay, usually when you go through the theory, like, whoa, what are we trying to get onto? Okay, so these are some examples that we're going to do, and then I'm going to, by probably next week, we're going to do something like this. I'm still trying to understand how this works. Okay, so this is like, holy crap, right? Will not be that bad, okay? I will not make you do things that is like really bad, okay? Let's do some simple stuff first, okay? And I believe all these are on Avenue to Learn, all these images. Come on. Okay, let's watch this, okay? Is the formulating the function. That's the tricky part. Okay, let's watch here. The bar DC rotates about the shaft at D with an angular velocity of omega. Okay. Determine the velocity and acceleration of the bar AB, which is confined by the guides to move vertically. Okay. So we want to determine what is our VAB, and we want to determine what is our AAB. The VAB and AAB is related to our what? To our omega, right? To our omega over here. And also is related to our arm over here. Can you see the arm? So when the arm rotates, right? So the arm has different positions. Okay, the arm has different position. So if the arm is at a certain position over here, so this is our point D, right? And then I'm going to sketch our arm. Okay, so this is where our point C is, right? And then depending on our theta, right? Our distance y is a function of what? Y is a function of theta. Okay. Now, given to us that we have constant what? Angular velocity. That is given to us. Okay. And then we are aware that this distance from here to here is L. Right? So C, with point C, is linked to what? AB. Yes or no? Right? C is linked to AB. Okay? So from here, we need to find, right? We need to find what is our Y. So we are able to relate our Y is equal to L sine theta. Once you formulate a function like this, right, you have to know the length is a what? Constant. Yes or no? You need to know what's a constant, what is a variable. And theta is a function of what? Function of time. Or time dependent. Right? So when time is equal to 0, theta is at a specific value, and because of omega, right, it will rotate and theta will change its value. So from here, we are going to do a time. So this is the hardest part. Okay, if you to ask me about this method, this is the what? Okay.